Hi, everyone, and welcome to our third day of the Blockchain Community Day conference. Today, we are going to continue our presentations and our workshops. And today, we will be having 6 amazing sessions dedicated to the future and to the interoperability topics. And we'll be having different sessions dedicated to topics like the interoperability trilemma, about safety in cryptos, about NFTs, about AI and cryptos, and about the role of tokens in the Web3 products. And first things first, this session will be dedicated to the topic of interoperability trilemma, the problem of fragmented liquidity, together with our esteemed guest, Boris Povar, who is a CEO of EYWA. And will be it's worth mentioning that we'll be having a simultaneous translation during this session. Please keep that in mind. Hi, Boris, how are you?
Hi, I'm fine, thanks.
Thank you for being with us today. I think we can, without further ado, we can start our today's session, and I hope we can now see your presentation on the stage, and you are good to start. Good luck to you. The stage is yours.
Thank you. Ну что, начнем.
So let's start.
Борис Повар.
My name is Boris Povar.
Я в крипте уже
I'm in crypto since 2017,
full-time, и с 2020
full-time,
года
and
я
since
занимаюсь
2020, I'm working
interoperability.
with interoperability
Я
topic.
CEO стартапа
I'm
EYWA,
CEO of EYWA startup.
который мы запустили в
We
конце
launched it in the end of 2020,
И в данный момент
and
мы
currently
также имеем
we
cross-chain
also
продукт, такой как
have a cross-chain
DEX
product.
with
It's a
Curve,
cross-chain DEX,
созданный в
cross-curve,
партнерстве с
created together in
вторая
partnership with Curve, which is
крупнейшая
the
децентрализованная биржа в
second
мире.
biggest decentralized exchange in the world.
Майкл Егоров.
And Michael Egorov, CEO of Curve, is our lead investor.
За это время мы зарейзили порядка
During
$7
this
миллионов
time, we launched about
решили достаточно много
gathered about
сложных
$7
проблем,
million and solved several difficult problems
сегодня
related
я
to this
хотел бы
topic.
подробнее
And today I
рассказать
would like to tell you
об этих проблемах
more about these problems
и о том, какие есть
and
варианты решения,
about
и
different
что
solutions that
сделаем
exist,
мы.
and also what we do in this relation.
Начнем с того, что
First, I would like to start
существует, на наш взгляд,
with
две большие проблемы.
two big problems that
Это
exist,
проблема
we believe.
фрагментированной ликвидности
It's
и
a
проблема
fragmented liquidity
безопасных
problem
cross-chain
and
communication.
insecure cross-chain communication
Я
problem.
начну более подробно с
I would like
проблемы
to start,
безопасности.
tell you more in detail about the security problem.
Я думаю, что многие из вас знают,
I
что
believe that many of
за
you do know
последние 3 года
that in the last
порядка
3
$2
years,
миллиардов,
about
на
$2
самом деле даже
billion,
больше,
and now it's even
украдено
more, were
с
stolen
cross-chain мостов и
from
cross-chain
cross-chain
протоколов.
bridges and protocols.
Поэтому сохранность
So,
денег
the
в cross-chain мостах
security of
вызывает
money in
большие
cross-chain
вопросы.
bridges raises a lot of
И даже
questions.
большие протоколы,
And even
которым
big
удавалось привлечь
protocols
огромный TVL,
that managed to attract big TVL,
большие деньги,
attract a lot of
крупнейших
funds
венчурных
from
фондов,
biggest venture
равно,
funds in the
сказать,
world.
садились в лужу,
And they made mistakes and
переживали большие хаки на сотни миллионов долларов.
survived big hacks for
Я могу
several billion
перечислить
dollars hacks.
самые
I
громкие
can list
истории.
the most
Во-первых,
noticeable
есть,
stories.
точнее, уже был такой
First of
протокол
all,
Poly
there
Network
was protocol called Poly Network.
китайских разработчиков,
It's
зарегистрированных
Chinese developers
Neo,
protocol, also
и
Neo
у них
developers,
проект.
and
В пике у них
it's
самый
Chinese
громкий
project
был
as well.
500
And
миллионов долларов.
they had a
И,
$50 million
деньги удалось вернуть,
hack.
благодаря
They
этому
managed
хакеру
to
нашли
get the money back because they
применение
found a
такой
hacker,
факт был.
but there was
Второй хакер
this fact,
протокол
it existed
потенциально
basically. The
исчислялся
second
несколькими миллиардами долларов.
protocol was
Но
several
удалось
billion
предотвратить.
dollars hack,
И,
but
на данный
they
момент,
managed to
насколько
stop
я
it.
знаю, проект заморожен.
And now the project currently doesn't work and it doesn't function currently.
Тоже китайских
The next example is another
это проект
project of
multi-chain.
Chinese developers. It's
Изначально
multi-chain.
назывался ENISWAP.
It was called
Потом
AnySwap at
переименовался.
some
Он
stage,
получил большую
then they
поддержку
changed
от
their
Андре
name.
Кронье,
It
известного
received Andre
лидера
Cronje's support.
крипты и DeFi
He is very
человека.
famous in crypto and DeFi.
Ну и, собственно, в
And so at the peak, there were $1.5 billion TVL, and it gave very great exchange rate for liquidity between blockchains. But unfortunately, it ended very sad, and also people who used it, about $120 billion were stolen, and blockchain suffered a lot, and Curve suffered from it a lot as well. It's the exchange that integrated this protocol as the communication layer. So why did this happen? In general, I can actually just give you many ideas. Wormhole, 300 million hack. Nomad Bridge, about 100 million, etc. And these are the biggest stories. And also smaller hacks did exist as well. If you wish, you can do your own research. And this time we were basically working on our own protocol. We were quite at an early stage, and we studied this hacked a lot and the nature of these hacks and why did they happen. And we came to a conclusion that the problem originally is in the architecture of the protocols, as to create, to make your solutions more fast and cheap. The developers basically used the simple decisions, and they made them centralized, their solutions, as some people did in the liquidity management, which was custodial, or how to say, I'll say decentralization of the layer communication, data communication layer was not enough. So let me stop at this stage. I will give you some more information on interoperability for maybe those who don't quite understand what that is. So the interoperability is created to transfer some data from one blockchain to another, because basically blockchains don't know anything about each other in general. They have their own finality. Each blockchain has its own finality. It's basically time when the block becomes finalized. So different algorithm of consensus, etc. And sometimes even different code base and different technology. And when we're talking about interoperability, we're talking that we need some sort of third party to transfer data from one blockchain to another blockchain. So this is a classical story about the man in the middle. So it's the man in the middle who can change this data. And so when protocols create solutions, centralized solutions, also it's called proof of authority. So it means when some special people are responsible for the security. So some group of people, small group of people, is responsible for this data to be transferred from one blockchain to another correctly. It's some servers, some nodes that transfer data, also called oracles. So when we made our first MVP on Global Hackathon, on Global Market Make Hackathon in 2020, I believe, we used Chainlink oracles. But this story was very short, as we realized that this story is fully centralized, and we cannot control that the codes that we place on oracles couldn't change. So we cannot control the hosts of this code, and the only choice was to host it ourselves, which means that we are the only people responsible for the security of data, or we trust someone. So the problem, the security problem of cross-chain, basically sticks in this level of decentralization. So the topic is interoperability trilemma, and I will try to phrase it now. It's very similar to blockchain trilemmas, which Vitalik Buterin stated. In fact, what three parameters do conflict between each other and which still need to be taken into consideration. First one is speed, the speed of the delivery of messages. And if this is a message, it's tokens, liquidity, swaps, etc. So it's some sort of interaction between blockchains. So the speed of this interaction is the first one. The second one is the cost. So it's the amount of money you will pay for gas and how much you will pay for the provider of this service. So it's the end cost for the user. And the third one is security. And as sometimes we say in some jokes, please choose two. So the most of these solutions, generally, they are some sort of compromise of the protocols. So basically the users choose the price and the security. So they need to choose two. So when we talk about the security in terms of cross-chain communication, we can say the same as, we can call it decentralization. We can say the same about it. So what level of decentralization is enough? This is kind of the question. And Vitaly Buterin thinks that the cosmos of blockchain, we cannot say that it's decentralized because it's BFT consensus, maximum 100 nodes. And if you are taking into consideration this approach, when we distinguish decentralization, for example, depose or proof of authority of any count is not a decentralization of the enough level. So taking this into consideration on cross-chain market, among the cross-chain solutions, there are not a single decentralized solution. So there are methods how you can make these proofs cryptographically. So there are several protocols that do this. I will give you the full classification below to show you what kind of solutions do exist on the market to solve this problem. But in advance, I'll tell you that currently in the cryptographic proof, so there is a problem that it would be secure, but it would cost a lot and it will be slow. So what kind of conclusions we can make in terms of security? So talking about security, we can say that currently there are several protocols exist in terms of data transfer between blockchains. So I mean general protocols, general interoperability protocols, but not a single one is fully decentralized and requires a certain level of trust to the team of validators who validate the transactions, etc. So generally, all these solutions are kind of proof of authority. So what happened with multi-chain? So the people who were responsible for the security, regulators or Chinese police, they caught them and they took them away. They took all the access to the protocol. So the work of the protocol stopped. It stopped working completely. It worked for some time, but it was not possible to improve anything or stop anything, etc. So this was the problem of dependence of the protocol on the team. So basically, the true solution doesn't have to depend on at least one team. So here, I will just give you some more classification. If we're talking about Trilemma, interoperability Trilemma. So what are the ways of solution? So the big cluster of solutions based on the fact that the third party is created between blockchains, which transfers data from one blockchain to another blockchain. In other words, oracles. And also, sometimes it's called verifier network, some sort of verifier network. And to decentralize it, so this decentralized network is created. And this network basically transfers data from one blockchain to another blockchain. In fact, what they do, so first they make sure that the block in the original blockchain is fully finalized, and it does exist. And this block has a transaction. sent by the user that it does exist in this block. So then this data is transferred to the destination chain. And originally, if it's a decentralized chain, they have to agree that this data is true. And so when enough people who confirmed that this data is correct, the consensus, a quorum takes place, and this solution, this is finalized, and then it's transferred to the destination chain. So this is a decentralized Oracle network. And so there are several solutions. And originally, we first were working on one solution. It's EYWA Oracle Network. It's a decentralized Oracle network that specializes on cross-chain data transfer. And we reached quite great, outstanding results. We managed to make it 150 validators, which is twice as more as the closest competitor, but this network was still proof of authority. So we had this opportunity that we weren't able to get rid of with censored the validators. So this, the solution for this would be to move to proof of stake, where the network could be made bigger, like let's say 1,000 nodes. But we looked at this, we looked at our competitors, and we took a different route. So the next classification, oracles, in this or another way. And in some projects, 3 or 5 nodes or 7 nodes or 10 nodes or 20 are responsible for this. So multi-chain has about 20 validators. Axelar, one of the projects, it has about 70 validators, decentralized network. Then another approach. When a centralized oracle is used, a centralized relayer that delivers the transactions. And the idea is that if oracle is owned by one person, the relayer is owned by other person, and then they cannot agree to cheat you, they won't be able to. And this is the layer 0 concept. So they say that the client can choose the data source he likes. It could be a decentralized network of some cross-chain validators. They call it decentralized verifier network. Or they can choose their own oracle, and they separate the delivery. So as we can see, this is some sort of an exception. We can accept that maybe this would never happen, that they won't meet each other and steal the money. But I think it's quite naive, as one of the hacks, one of the biggest hacks, and I'm talking about Ronin Bridge, it's Axie Infinity project. It's a very big GameFi project. They had their own blockchain, and they had their own bridge, and it had 9 validators, and basically they lost hundreds of millions of dollars. So through the social phishing, hackers send some spam messages to their emails, and engineers somehow, we don't know why they opened these messages, and they infected the machines, and the hacker got the majority in this consensus, and the money was stolen. And this is basically on topic of no one being able to meet and agree on some. And so basically there is a problem exists. I call it the black swan effect. Big projects, and I will give you 3 names: Axelar, Layer 0, and Wormhole. They build their own ecosystems where tons of projects integrate them as bridge, or some projects build their protocols based on these projects, where they somehow unite cross-chain logic. And so if one day one of the risks that there is a bomb underneath every single architectural solution as this will be exploited, then the full ecosystem will be ruined. And many projects will suffer, projects that used it. So they might lose the money, or maybe some functionality will stop working. So it's a potential risk of a black swan. So this is the big problem. So I told you about these possible solutions. There are some solutions that are more true, some cool solutions cryptographically that deal with the check of Merkle proofs. So they don't trust some third party to say that it's truth or it's lies. They prefer to check in the destination chain the correctness, the truth, that the block from the source chain and the transactions that they do exist in the global state of the original blockchain. So they check it through the Merkle tree. So what's wrong with these solutions? First of all, the most famous solution that was developed is a near Rainbow Bridge. It's a bridge from near to Ethereum blockchain. These are very different blockchains. They have different code base and different cryptography, but they solved this problem. So this solution is quite universal, and it can be used for other blockchains. But what's wrong with it? So to prove that the block exists in the global state of a blockchain, you need to have this state. So you need to have all the headings of the blocks from blockchain A. So if we're moving from blockchain A to blockchain B. So if you need to prove that in blockchain B, that the block exists in the blockchain A, you need to have the full information, the full stack, the full information on the full blocks of blockchain A. So we need to have some sort of servers who will provide these blocks. Theoretically, the source of these blocks could be malicious too. So the information can be changed. But these are small details. The main problem is that every header needs to be loaded. And okay, there are some solutions to make this problem easier. Some solutions that allow to load some smaller parts to realize what is the state. But if we're talking about connection of 10 blockchains, each blockchain with each blockchain. So each blockchain with each blockchain has to be connected. In this case, this solution is impossible to use, as you will need to upload all the states of all the blockchains in every single blockchain. But it looks like this solution is a true great solution. You don't need decentralization. You basically prove that the transaction does exist. But this way is very expensive and slow, especially for blockchains like Ethereum, slow blockchains. And also there are several other solutions, interoperability solutions that are fully decentralized or fully centralized. So for example, when there is one server in the middle and it just transfers data from one blockchain to another. For example, when we're talking about classical cross-chain link oracles, I told you about Chainlink. Now they have Chainlink CCIP solution, Chainlink Interoperability Protocol. So they basically use Chainlink oracles, and they have some sort of consensus from these oracles. But when you look deeper, you can see that it's an authority consensus. So there are special people, special groups of people who are responsible for this. And this is quite small circle of people, so the potential the amount of malicious players still exists. So now I told you about the main ways of working on interoperability. I didn't tell you how to do it with Bitcoin. I'm more talking about EVM chains. If we're talking about interoperability with Bitcoin, the problems are quite the same, but there is an additional problem as Bitcoin and similar blockchains doesn't have the full EVM machine, which can make the code. So there are several solutions on interoperability with Bitcoin. For example, Tor chain protocol. They are one of the first ones who made the solution. Also, REN protocol, but it doesn't currently work. They stopped it. And now I would like to go back to the problem, what to do then? What can we do? From our side, we have some code in this direction. We call it a consensus bridge. EYWA protocol has EYWA consensus bridge solution. So it's now in audit, so it's fully developed. So what's the idea? As I said, data transfer protocols, there are several of them. There are quite a lot of them. In 2020, there were no protocols like that. So that's why we started creating one. And currently, there are several ones. There is a choice of protocols. And as I said, none of these protocols is a trustless, permissionless protocol. So every single one, if you look into detail, every single protocol has its own risks. Now in the picture, you can see Warhol, Axelar, Layer 0, Chainlink. As I did say about Wormhole, that $3 million were already stolen from this, and there are some kind of guardians, validators, and it's 20, 30 of them. Axelar has 70 validators. Layer 0 concept is the concept about splitting the validation and data transfer, and you will have no problems. But potentially, it still can exist. CCIP, yes, they have several groups of oracles, but they can be censored. So it's not a decentralized solution. So what can you do? And we offer following concept: to protect data transferred between blockchains, and to protect, for example, liquidity that's in a bridge. We offer to do hedging. So it means that when the data is sent from chain A to chain B, we can send this data using several protocols and then match the result. For example, let's look at the simplest example. Let's take Axelar and Layer 0 protocols. We have some transaction. For example, a user, just a simple bridge, and the user sends a token from one chain to another chain. So it's lock and mint, where in one blockchain we block liquidity, and in another blockchain we mint a token provided by the liquidity blocked in the original blockchain. So to make this transaction safely, what can we do? So we can transfer data, the main data, so-called payload. So the main information, where it's coded, where we send the call, to what smart contract, and what data we want to send to that smart contract. And for example, we use Axelar. We send this data with Axelar. And at the same time, we send this data with the second protocol. Oh, you can say, oh, that's very expensive, double spending of gas. And you will be correct. So how you can save your money? You can take a hash from this data and send the hash. So it will be a lot less information. And after that, the contract of the bridge.
моста для передачи данных, да?
We will say, we
он
so
получает
call it,
основные
the
данные
data
первого
bridge.
протокола.
It receives the main data from the second bridge, and from the second protocol, it receives a hash for the same data, and it knows what hash it should be. And if it fully matches,
Он делает
then
вывод, что
he
оба протокола
believes that
подтвердили,
both protocols
что эти данные
proved
корректны.
that this data is
У них
correct.
совпали данные.
So
Что произойдет в
the
случае
data matches.
некого zero-day уязвимости какой-то
So
из этих
this
протоколов?
zero-day.
Они начнут
So if
передавать
one of these
некорректную
protocols is
информацию.
hacked, then they will
Как
start
схема на
sending
большинстве мостов.
wrong information. How most of the
Прикинь,
bridges were
Боб отправил $1000
broken.
в мост.
One for Bob sent $1,000 to a bridge,
Destination сети сказал,
and
что
in
Боб
the
отправил $1
destination
миллион.
chain, the bridge says
После
that Bob
этого
sent $1 million.
destination сети Боб
And
забрал
in the
$1 миллион,
destination chain, Bob
оттуда
takes
ссылку
$1
всю
million
информацию.
and
В итоге
basically takes
другие
all the
люди,
money.
которые не успели
So
вывести
other
свои деньги,
people who
они
didn't
остаются
have
просто с
time to
компанией.
take their money out, so they are
И
left
теперь
with
они обеспечены liquidity.
some papers not
Почему так
provided with
произошло? Потому
liquidity.
что кто-то подделал
Because someone
данные о том, что
changed
Боб
the
переправил
data
не
about the
$1000,
fact that Bob
а оказывается миллион.
transfers
И
not
чтобы этого не
$1,000,
допустить,
but
соответственно,
$1
вот это
million.
хеджирование, для
So
этого и призвано. То есть
that's why
если
we
мы
use this
понимаем,
hedging.
что у нас хэш и
So, for
payload не
example, when we
совпадают,
understand that
значит,
hash
мы
and
берем русское
payload
какое-то из этих
don't
протоколов
match,
используем.
then we
Мы
believe that one of these
делаем
protocols
реверс.
is
То есть мы не отдаем деньги.
hacked.
Ну, и в случае
So
конкретно
we
с этим
don't
бриджем.
risk the money and revert,
Транзакции. После
and we
этого можно будет
refuse
деньги
to
просто
complete the
оставить.
transaction.
Без
So
копии
you
сети,
would only be able to
комиссии.
take the money in
Клиент
chain
их может
A,
забрать.
the client
Он
who
свои
would
деньги
take the
в
money
destination не получит.
in
Но самое главное,
in
что они
chain A,
будут
and he won't
что
receive the money in the
ничего не будет
destination chain.
украдено при этом.
So, and nothing would be
Таким
stolen.
образом, наш протокол позволяет
So this way, our
создать любые
protocol
консенсусы из различных
allows to create any type of
cross-chain messaging протоколов.
consensuses
То
from
есть, поскольку
any
я сказал, что все
cross-chain
эти решения
protocols.
плюс-минус proof of
So as I
authority,
said, that all of
базируются
these solutions are pretty much
на
proof of
трасте
authority.
доверия вот этим
It only relies on the trust
ребятам. Вот у нас, например,
to
тоже
these
есть
guys.
свой месседжинг протокол.
So, for example, we
EYWA
have our
Oracle
own
Network. Мы
messaging
его в том числе
protocol. It's
используем.
EYWA Oracle Network, and we use it as well.
Объясню разницу, да?
And
Для
I will
чего нужны
explain you the
несколько
difference.
комплектов
Why
разных
do we
протоколов?
need several
У меня
sets
будет
of
задача,
different
вот мы
protocols?
работаем с B2B. Может
For
быть
example, we
задача,
work with
вот,
B2B.
например, мы работаем с Curve Finance.
For example, we work
И
with Curve
у
Finance,
Curve есть такая задача,
and
что
Curve
есть
has
эмиссия сервера.
the following.
Это их governance токен. И
So they have the emission of CRV.
Он
All the
выпускается
incentives are paid in this
соответственно,
token,
на
and it's
layer
issued
2
on
сети,
Ethereum. So
где
layer
есть
2
нативные
chains,
мосты, он еще
where
дальше
there are
продвигает
native
в
bridges,
одну сторону.
it can get
Быстро, в другую
there
сторону не делится.
very fast in
А
one
вот если мы
direction and
говорим про
quite
layer 1 блокчейны, например,
it takes
Avalanche,
quite a long
Binance
time.
Smart Chain, там,
But if we
и
talk about an Avalanche
вот
or
еще
Binance
блокчейн
Smart
можно
Chain,
туда эти инцентивы не попадают, потому что
it's
моста сейчас
impossible
нет.
to deliver these
Для этого
incentives there because the
множественный
bridge
блокчейн,
doesn't
который
exist. For example,
сломался.
before that, there was
Вот.
a
И,
multi-chain bridge, but
соответственно,
now
им нужно
it
передавать
doesn't work.
из
So
treasury
they
протокола
basically need from the
достаточно серьезные
treasury,
суммы,
the protocol
серьезные,
treasury,
много,
to
там, ну, скажем, на
bridge
$1 миллион в среднем
quite
передавать, или
a
10
few
миллионов.
$1 billion
Они
CRV,
готовы заплатить больше
and they
за
are ready to
безопасность,
pay more for
выбрав
the
те протоколы,
security
которые они
and
хотят видеть
choose the
в этом
protocols they
консенсусе.
want to see in
Например,
this
они говорят, мы
consensus.
хотим
So,
там
for example, they want
Chainlink, Layer 0 и
Chainlink. They
XLR.
say we want Chainlink, Layer 0, XLR.
Такого, да?
Let's say 3 protocols.
И они понимают, что по
And
газу
they
это будет
understand
сейчас
that
сложно.
gas-wise it
Но
would
когда
be a
им дают
lot
несколько
more
миллионов долларов,
expensive,
им важнее
but when they transfer
сохранить
several
эти
million
деньги,
dollars,
нежели
it's more important
экономить
for
там
them to
$100
save this
на
money
этом.
rather than save
Но для ритейл-пользователей это очень
dollars on
критичный вопрос.
the
Поэтому можно
transaction. But for
использовать,
other users, it can be very critical.
создавать
So
комплект
you
консенсусный,
can
в том
make a
числе для
set, a
ритейл-пользователей.
kind of
Брать
consensus
какие-то
set,
протоколы более
so
дешевые.
you can
Например,
choose cheaper
наш
protocols.
Oracle Network,
For example, our Oracle
при
network,
сравнении там, с XLR и Layer
in
0, он
comparison with XLR and Layer
существенно
0,
дешевле.
it's a lot
Плюс мы
cheaper.
сами с себя не берем никаких
And also, we
комиссионных.
don't take
Газом
any
мы дешевле,
commissions.
по комиссионным,
So
соответственно,
gas-wise,
нет.
we're cheaper, and commissions is
И,
0.
ну, это по другой причине, потому что у нас еще DEX, да, работает поверх этого моста. И мы
It's
один наш
because we
продукт
have DEX
сделал
on
нашим
top of this
пользователям
layer. So one of our products doesn't take money from the other product. So you can choose a different consensus. And the user, be it a B2B or B2C customer, he can choose some kind of a flag that I want to use this consensus. Please use these bridges to transfer my transactions. I want EYWA plus layer 0, for example, or I want Axelar and layer 0. So there will be several sets to choose from. So the idea is that this way, first of all, the security issue would be solved. So it decreased several times, as the risk is the same as imagine two big independent protocols would be hacked the same day or exploded. Okay, we do take into consideration that smart contracts are audited. This has to be taken into consideration as well. But this is also just solved with the amount of additional audits. And also with bug bounty for white hackers who can find exploits that were missed by the auditors. So this is talking about the security. And talking about the speed and price, I will give you some detail. So basically, if we're talking about interoperability between blockchains, you cannot make this speed very fast, like 1 second, because it depends on the two blockchains that do interact. So for example, if one of them is slow, then the transaction will happen with the speed of the slowest blockchain. And I'm not talking about the speed of block production. I'm talking about the finalization speed. It's not about how many blocks created in whatever seconds. It depends on how many blocks you have to wait to make sure that the block is accepted in the main chain and it exists. So these two factors determine the blockchain finalization time. And if the blockchain solution starts to transfer money faster than the real finalization, it's some sort of compromise. So you can make one confirmation for Ethereum and send the money straight away. But in reality, after proof of stake, after Ethereum moved to proof of stake, there could be block restructured, and this block won't be taken into the main chain. But the protocol, for example, already worked, completed the solution and gave the money in one blockchain. We kind of took the money and gave the money to the user in the other blockchain. But the money we took, it could be in the end of the day that we wouldn't receive the money, and so it would mean that we lose the money. So we kind of go into this place where it's we need to compromise between the security and the speed and the convenience for the user. So if you go to different centralized exchanges, the speed of the deposit being loaded and the speed of the time that it takes to take out the deposit, we did research and the speed would be different. And we looked into this security and what's the secure number for each blockchain. For example, Polygon. Polygon is a super fast blockchain and cheap. It's kind of layer 2 of Ethereum. But if you look at it, the finalization speed in Polygon it can vary, and it varies from 200 blocks to 400 blocks. So for interoperability, it's a very hard blockchain. So you need to set a very long waiting time to make sure that the transaction won't be reverted with a mistake. So it makes this blockchain one of the slowest layer 2 blockchains. So this is what I wanted to tell you about the trilemma and the security. And let's go back to the second problem. The second problem is the fragmented liquidity problem. So what that is? We all know that the amount of blockchains increases all the time. New blockchains appear, L1, L2, different technological stacks. But let's not, let's just take Ethereum into consideration, that there is Ethereum and a lot of forks, like L1 forks and different layer 2 blockchains. The classical approach is not effective as, for example, decentralized DEXs or lending protocols, all DeFi. It works in a kind of way that it's a single chain story. So if we want good slippage, when we do the exchange, we need a lot of liquidity in one sort of pool, in a DEX. But if we want a good lending percentage, we need to have a lot of liquidity in the lending protocol. So when more and more blockchains appeared, they only repeated and repeated and repeated this scheme in each blockchain. So because there was no interoperability at that time. So from zero, they built the whole structure, the whole liquidity structure in every single chain. So this is a classical approach. And so what is the problem? For example, there is a lot of liquidity in one blockchain, but it doesn't affect another blockchain. And for example, let's see, imagine you are a builder, you are a project or a team that launches some DeFi protocols. Or it could be a project more like social fi, mem coins, NFT, GameFi. So one or another way, they have to launch the token. So what kind of pain do they have? If they want to work in different blockchains at the same time, simultaneously, so the users use some sort of their product or just bought their token in different blockchain, they face this problem where they need to split their liquidity in parts and place into several blockchains. And the less liquidity they have, the worse it would be for the end user. So this is the fragmented liquidity problem. So the liquidity cannot be used several times in or simultaneously used in several blockchains. So for a long time, we looked at this problem, how to solve this issue. And we were solving it in relation to cross-chain bridges and bridge liquidity. I believe that all of you do understand that for some bridge to work, especially if it's not some canonical layer 2 bridge between Ethereum and some L2, but a cross-chain protocol that has to make swaps in all the directions and all the different combinations, it needs liquidity, and quite a lot of liquidity to make sure it works in all the directions. And the problem is that classical bridges don't solve this problem. So they connect assets and blockchains. For example, USDT in Ethereum, we connect with USDT in Binance, and we need to place liquidity in each blockchain. And imagine that there are 10 blockchains like this, and there are other 5-6 assets, and in each blockchain you need to lock these assets. So it doesn't solve the liquidity problem, the liquidity fragmentation problem, and it even makes it worse. And in several blockchains there is a lot of liquidity, and in other projects there is less liquidity, and the project needs to build its liquidity in the blockchain where there is more liquidity. But every blockchain has some sort of superpower, so-called layer 3 chains. When a project launches its own blockchain, and it will have the same problem: how to get liquidity in that blockchain. Where would it come from? So the lack of liquidity is the global problem of the whole market. Every blockchain, every new blockchain needs liquidity. Every protocol that launches anywhere needs liquidity. And so what is our solution for this problem? We offer this sort of approach where we work with the derivatives of the liquidity. And this way we connect different liquidity from different chains in one place. So we use a star topology. Instead of using the classical way when connect each chain to each chain and we need liquidity in each place, we connected all the blockchains in one center, so-called hub chain. Currently, we use Phantom as it's cheap and fast. And moreover, it will soon go to the next level of its development. They already announced their branding. It will be called Sonic, and its TPS would be twice bigger than Solana. 2,000 transactions a second. Now it's 59 transactions a second, and it's one of the best number among all the EVM chains. And there is quite a big amount of gas. Gas is cheap, and it's very good to use for calculation. So how we connect liquidity? We have a strategic partnership with Curve, as they have more than 2 billion liquidity, and they have similar type of pools in each blockchain. For example, stablecoins pool and volatile assets of the same nature. We use the liquidity, the existing liquidity of Curve, and we can reuse it. So how does our solution work? There is a bridge that connects every single chain with Phantom. So basically, bridge really connects all the chains, but I'm just explaining you the liquidity structure. So we connect each chain with the center, which is Phantom now, and then we can add assets in the bridge like stablecoins, Ethereum, Bitcoin, everything that everyone needs everywhere. And also we learned how to do it with Curve LPs. So for example, there is a liquidity pool in Curve. There is a liquidity provider that receives LP token that he's an owner of this liquidity, and we can bridge these LPs. And based on these, on Curve again, we create a standard cross-curve, standard Curve pool. As we use the same nature assets, it's basically a stable pool. It's what Curve is famous for: exchange of the same nature assets with very low slippage. So in fact, this solution works the following way. If we use the Curve pools, the client adds liquidity in a Curve pool in one blockchain, and it takes it out from the Curve pool in another blockchain, as there are several tons of billions of dollars in this system. So do we need liquidity in Hub? Yes, we do. We do need some liquidity in this core, and we attract the liquidity. And this way also solves the problem of balancing liquidity. So, for example, when the flow of liquidity goes from one chain to another chain, so in the original chain, there will be no liquidity left. So how it worked originally in multi-chain: if you send from chain A to chain B, and if there is not enough liquidity in chain B, they just gave you synthetic asset and they said, come back later when we have more money. And in our case, it's impossible to have this sort of situation. You basically make an cross-chain with AMM. So, for example, if there is a lack of this activity, it will become just more expensive, and maybe you won't even make this transaction, but it's impossible to take out all the liquidity. And when there is a disbalance, then their arbitrage opportunity arises. It appears, so for example, if I have USDT from one chain and another chain, and it costs a lot more in the chain where it's a lack of it, so I can make the other way transaction. So I can add the asset that's lacking and take out the asset that exists in a big amount, and he will take out just more. And the main thing is that these are derivatives. So we create the first layer of derivatives with our bridge. So every single bridge does it, even Axelar. All the tokens minted by bridges are derivatives. Then we put them in one pool that has an LP token, and it's a derivative too. So it's an asset that's a concentrated cross-chain liquidity. This asset can be turned into any asset in any chain, and it can be reused again. And here, the liquidity fragmentation problem is solved. So in classical bridge, let's take Arbitrum Optimism layer 2 bridges. So there is a huge amount of money locked in Ethereum, and assets in Arbitrum are minted. So do you think this liquidity can be somehow used? No. Why Blast? You know why Blast was so successful? Because it said, guys, this money set in the bridge, I will place in DeFi and give you 3-5%. And it got billions of dollars. And we do the same with the bridge liquidity. But we also use already wrapped liquidity. We take LP token that makes money simultaneously in two places. So there in the source chain and the blockchain, there is an LP, and we reuse this liquidity. And in the aggregated pool with these assets, the final LP token, backed by all the tokens I told you about, it can be reused again. For example, you can see 6 blockchains. For example, there is a pool with 6 assets, and every single chain is from a different chain, and we swap them in between. But for example, if I want to connect 5th and 7th, 8th blockchain, there is a mechanism exists. So I can take an LP of this pool and create a new pool with this asset and add some other asset from a different chain. And this way it can be, and it can grow bigger. So this is a liquidity fragmentation problem. And if we're talking about the projects and needs of projects, using these solutions, we can give a project an opportunity to create one liquidity pool in any chain the project likes. For example, Arbitrum or Binance. All their liquidity with its token they place there. Using this system, we give him a routing where a user can take any assets from any other chain and receive a project's token in Binance. And if the project connects its token to the bridge, and also the client would be able to receive this token in a different blockchain. So you can trade a token in a blockchain, in Arbitrum, but there is no liquidity for this token in this chain. All the liquidity for this token in a different blockchain, but you could still trade it. It's very similar to CEX. So in CEX, you deposit, you wait, then you trade and take it out. And we do it on-chain in one transaction. So here, interoperability is the way that in one transaction, we make several cross-chain transactions, depending on the solution. It could be 2 or 3. So it's kind of this journey of the liquidity between blockchains that takes place automatically. So this is what we were working on. And this is what venture funds liked. So when we rebranded the project, so it's a cross-curve project now, and then it started working. And apart from the technical side, yield is important in DeFi. DEX is like curve, velodrome, and similar. Those who use voting escrow economics, they give a long-term incentives on this liquidity, and it allows projects to build liquidity long-term, and we will also use it. Thank you for your attention, and maybe if you have any questions, I'm more than ready to answer them.
Yes, thank you so much, Boris, for delivering such a great presentation. Let me quickly check out the live chats on several sources where we have been streaming the conference, and I will address them directly to you just in a while. So, yeah, we see the first question. The first question says, what has been the market and user response to EYWA cross-chain protocol so far?
Спасибо за вопрос. Прямо сейчас
Thank you for your
мы
question.
объединяем
Currently, we connect
6 блокчейнов,
6 blockchains,
помимо основного блокчейна Phantom,
apart from
это Ethereum, Arbitrum, Polygon,
just 1 second.
Binance Smart Chain, Avalanche. И мы работаем с рынками. Мы уже работаем с
We already work
блокчейнами.
with 6 blockchains:
Ethereum,
Arbitrum, Optimism, Avalanche, Polygon,
Binance Smart Chain.
and Binance Smart Chain.
И мы объединяем
And we connect liquidity pools like
CRV-USD,
USDT, and CRV-USDT, USDC.
а также 3 криптопулы,
And also 3 crypto pools:
где обмениваются
Bitcoin, Ether, and USDT.
И в скором времени,
And soon,
неделю, мы покажем
in the next week or two, we will show you another pool that combines the biggest stable pools of curves, like 3 pool.
В разных блокчейнах
in different blockchains, it's called differently: 2 pool, 4 pool, and 3 pool, etc.
И мы добавляем новые блокчейны.
And also we are adding new blockchains like Base, X-Layer.
Это новый блокчейн.
These are new. It's a new blockchain of OKX.
А также в пайплайне у нас
And also there are several other layer 2 and layer 1 chains in the pipeline.
Например, из ближайших это Gnosis,
For example, Gnosis, Linear, ZK Sync,
Blast, Scroll,
Mantle, etc.
Okay, yeah, thank you so much. And the next question comes from Dmitro. He asks, how does EYWA protocol contribute to solving issues related to blockchain scalability and growth?
Если говорить про scalability,
yes, talking about scalability,
я имею в виду в первую очередь
first of all, I mean the growth of the amount of the liquidity in blockchain.
И фактически мы предоставляем
In fact, we provide a fast way for blockchains
привлечь ликвидность
to attract liquidity
из тех мест, где она
from the places where there is a lot of liquidity. For example, we are the only protocol that allows to exchange LP tokens directly between blockchains. In partnership with Curve, we offer the following scheme. Blockchain integrates Curve. After that, it creates a typical pool like 3 crypto pool or 3 pool. And basically it gives a good incentive. And after that, the liquidity provider from Ethereum, they can quickly go to that blockchain to receive a big yield. As asset management fund manager, I can tell you that the money between blockchains move towards the higher yield.
Okay, thank you so much for your reply. I think that was the last question for now, but I'm sure we will receive a lot of other questions when we publish the recording of this session on our YouTube channel. I will definitely address them directly to you, Boris, after we do it. And I'd like to thank you so much for being with us today and for delivering such a great presentation. And I would like to say thank you to everyone who joined our today's live session. I'd like to remind you that's not it for today, since we will be moving to Microsoft Teams to have our workshop together with Dmitry Burov, who is a Chief Product Officer, and we'll be conducting a workshop dedicated to the topic of building seamless dApps with Power Cloud, leveraging interoperability in full stack development. And the link is in the live chat and in the descriptions wherever you are watching this session. And thank you, Boris, so much once again. We will be very happy to see you again in the future on our stage.
Thank you for your time. Bye.
Bye-bye. Thanks. So yeah, see you in Microsoft Teams in a couple of moments.